name is Karuna Singh. Welcome to the channel Knowledge Star Continuous Knowledge Excellence. In this video, we will get to know about the detection of neurotransmitters. Now, our expert, Professor Himadri B, Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Titan Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
These are now physical examples. So, we will do electrochemical detection of neurotransmitters. Neurotransmitters are very, very important for neurosignaling and nerve control and other things. And few of the neurotransmitters are listed here: dopamine, catechol, caffeic acid, serotonin, and all these things. Now the question is, can we detect these neurotransmitters through the cyclic voltammetry or electrochemical method? Okay, that is the challenge. And if we want to target one particular neurotransmitter, can it be observed in the background of other neurotransmitters which are present in the dispersion or in the solution? That is the challenge. So let us see how that has been done. As you must have realized by now, all the game is happening on the electrode surface. And the electrode, which is actually playing the crucial role here, is the working electrode. So your efficiency of the electrochemical process that you are designing depends very much on the design of the working electrode. So the working electrode has to be designed in a very intelligent manner. And this is where the nanotechnology comes into picture. For instance, here we will make a working electrode where gold nanoparticles will be providing the efficiency or efficacy and faster electron transport to the electrochemical cell. So first is designing the working electrode. That's what we discuss right now. So for that, we need to make gold nanoparticles first. Gold nanoparticles can be made in the standard chemical reduction process. You start with a gold precursor, HAuCl4, which is a standard precursor used for synthesis of gold nanoparticles, is fluoroauric acid, a particular concentration which is mentioned here. Then it is mixed in a solution with polyvinyl pyrrolidone, which is a reducing agent, also a capping agent. You can mix them with different molar ratios. Reaction happens at room temperature, but under basic conditions. So you have to drive the pH towards the basic side, something like 10 or so. So we let the reaction run for a couple of hours.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
And after that, you will see the transparent initial solution turning into red-violet color, signaling that the nanotization of the product has already taken place. After that is basically filtration and taking out the aliquots from the preparation and purifying it. So this is as far as the making the gold nanoparticle is concerned. Now we have to put it on the electrode surface to make the working electrode. So the electrode that is chosen here is a glassy carbon electrode, which is very standard in electrochemical cells. First, it is polished with alumina powder of different particle size here mentioned here. Then you wash it repeatedly, sonicate it for a while to remove all the grease and other impurities that is sitting on the surface. Next is a colloidal dispersion of the gold nanoparticles in water is made, and then you dip this electrode in that solution certain amount of time, which can be for 15 minutes to about 2 to 3 days. Okay, now your electrode is more or less ready for use. Okay, prior to that, of course, you remove all the water and dry it under a nitrogen flow to just make the surface smooth and homogeneous and free of impurities. And again, like have been mentioned, in the past, yesterday, we used three electrode configuration: working electrode, reference electrode, and a counter electrode. Now, for this, as far as the synthesis of gold nanoparticles is concerned, if you change the molar ratio of the gold precursor to PVP, polyvinyl pyrrolidone, then you can make gold particles of various size and shape. This is the molar ratio between the two. Okay, gold precursor and PVP. If you take a UV visible absorption spectra of this, you will get a absorption peak at 520 nanometer when the particle size is about 3.5 nanometer. Okay, as the particle size that you see for a different concentration, the absorption maxima now shifts to a higher value continuously, 525, 27, 565 nanometer. Correspondingly, the color of the solution also will change from pink to dark red. A red shift in the color basically means larger particle size. That's what also implied by lambda max here, which is moving to the larger lambda value. So the mean diameter now will change from 3.5 to going to up to 22, close to 21.5 or so. And the particles start becoming a little asymmetric. So you have full control over the morphology of the gold nanoparticle by changing the precursor to PVP, which is the reducing plus capping agent in this particular synthesis protocol. So this is what I said. You take the UV visible spectra, you will see that as the particle size increases from 3.5 to 21.5 nanometer, this peak is going to shift from the initial value, which was A here, to D here. So there is a shift here, red shift. That also gives rise to change in the color here.
I hope you liked the video. Here I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organized the nanotechnology workshops on amazing topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of: mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. One more thing, and that is, if you want the full recording of the previous videos, so you can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshops, then you can go to the website www.nanoschool.in. And yes, subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.